So we're going to go on and do an SDS PAGE gel. So that's a protein gel that's going to allow us to look at and see what our samples look like. We've had lots of other ways that we can tell whether there's protein there or all kinds of other things. But right now, this is going to be sort of the most clear method for us to kind of tell what's going on with our solutions. So here are some of the materials you're going to need. So we've got all of our protein samples that we're interested in analyzing. So these are ones from an overexpression that was done. Maybe you want to have an authentic sample. So this is because we're doing something with malate dehydrogenase fused to our green fluorescent protein, so MGH. We've got an authentic sample here. You also probably want to have a protein marker that you're going to be using on your gel to kind of assess for molecular weight. But because we have an authentic sample here, that's going to be our best gauge of kind of size. Right now we have some precast gels that we're going to be using. In the future, we're probably going to start pouring our own gels. We need our electrophoresis power supply, and then we need our electrophoresis chamber, which is going to be filled with about 1 liter of our SDS PAGE buffer. So this is a 10x solution, so we're going to use 100 milliliters of this, diluted approximately to 1 liter. We can just use the measurements on this beaker here to generate our running buffer. So last piece that we're going to have here is when we put our samples together, we're going to mix them with this loading buffer. So this buffer is going to be mixed 1-to-1 with all of our samples. This small gel uses 15 microliter wells. So we've got 15 wells that hold 15 microliters each. So if we prepare about 40 microliters of each of our sample, depending on how much sample we have, but we can use 20 microliters of our sample mixed with 20 microliters of our buffer. We can use a separate tube for that. We're going to need to make sure that we boil these for about 3 to 5 minutes before loading. So we've got a heat block right now that's set at 90 to 100. But we're going to go ahead and get our samples ready here. We're going to use new Eppendorf tubes, and we're going to take about equal amounts of these protein samples with our loading buffer. Again, if we do about 20 microliters to 20 microliters, that should be good for that. Just a little time-saving strategy as you're putting your samples together. More often than not, you're going to have plenty of sample here that you're going to be analyzing, so you're not taking all of it to analyze on a gel. So rather than labeling these tubes with a lot of information, you can just write 1 through whatever, and then have a separate piece of paper that you label what those correspond to, and that'll save you some time in the lab. So a couple of other little tidbits here as you're getting ready to start adding all of your solutions to your Eppendorf tubes that you've labeled is in our attempt to be green versus clean, right? This is something that's going to go into all of our tubes. So if it's the first thing that's going in, we can use a single pipette tip to put it in all of these because there's nothing else that's there. And then when we add our proteins in, we can also use that same pipette tip to nicely mix that solution. And then we'd obviously have to get rid of that pipette tip, which we'd have to anyways because it was in a unique protein solution. All right, so we're ready to put all of our pieces together here. So I've got 900 milliliters of water here. More important is I'm measuring this 100 a little bit more accurately. By the way, this really shouldn't be yellow. It's old. We need to get some new stuff. But we'll probably start making this from scratch as well. So I've got 100 milliliters here. Now keep in mind, this is a soapy solution. So we want to make sure we're not doing too much to kind of agitate or stir it up because we're just going to make for a lot of bubbles. So we're going to go ahead and put our gel in here. So we've got our little system here. We always want to make sure that we have this guy being on, the red has to match up here. So you can either have it in the front or the back. This will actually hold 2 gels. So we're going to put our gel in the front, and then I'm going to have to go find where our damming piece is so that we can have that in the back. But we'll get this set up and then we'll find that other piece. So these precast gels, anything that is green on here, we're going to want to get rid of. So there's tape that's at the bottom that we're going to take off here. And then this comb is going to come out. The nice thing about these gels is they're actually labeled with the wells so you can actually see them. So anytime you pull out a gel comb, you want to pull it out as straight as possible so you don't do anything for the wells, but we can see now that those are nicely labeled. We're going to be able to see them. So I'm going to put this here like this, and then we're going to have to pause our video because I'm going to have to go get. So if you're only running one gel, you're going to need to have kind of a dummy gel on the other side. Here it says this side goes towards the gasket. So we've got our one gel in here. The other one's going to go on the other side. And you literally just kind of bring them together to make a sandwich. Double check. We want to have the small plate on the inside. That's really important here. The numbers will be backwards anyways if they're not. But then we just close this up here, and then this is going to set in here. We're going to add our gel buffer to the inside here. You'll notice on here it says there's different levels, whether you're running 2 gels or 4 gels. So we're going to take this. I always like to pour it on this inside part first, so we make sure we fully fill up this part. We're actually going to have to get a quick check here. Oh, look at this. I'm glad I did this here. Do you see how this is leaking here? This is going to be a problem here. We're actually going to go get our other assembly, and we're going to reassemble this, and we're going to make sure that we don't have a gel that leaks. All right, so we swapped this out. There was a reason that this one was sitting in the cabinet, because I think that that one has a bad gasket. So we're going to go ahead and do the same thing. We're going to fill up the inside here, and we'll give a quick check. I'm going to make sure that we don't see anything leaking. And it actually looks like it's probably good. Okay, so I'm going to go and fill up the outside here. I'm going to fill it up to the 2 gel mark. Okay, could have a little bit left over, that's fine. We'll just kind of dump that down the drain if we don't need it. But now we're going to go ahead and get our samples ready. Okay, so I always like to use this heat block on the right for anything that's going to be high temperature. So right now, if we look at the thermometer, it's actually like reading like 125 or something like that. But this is a dry heat block. So I'm going to take some distilled water. I'm going to put it in here. It's going to sputter and spurt, and that's fine. But what's going to happen is I know that this water in here is going to be 100 degrees, right? Because anytime water is boiling, I know that it's going to be 100 degrees. So I'm going to fill up 15 wells here, so that we're going to have 15 samples. We're going to be putting our samples in here because we want to make sure that we fully denature any protein. Remember, what's happening with SDS PAGE is that soap that's in there, that SDS, is helping to unfold or denature our protein, and then the SDS is coating it in a negative charge so that we have polyanions, because we need that in order for proteins to migrate in an electric field. So I'm going to put these in here. The time is not exact, but somewhere between 3 and 5 minutes. We're going to put these in here and just let them boil a little bit, and then we'll come back, we'll centrifuge them, and then we'll be ready to load. So you can even see as we're pulling these out that there's a lot of condensation on the top of the tubes, because the top of the tubes is relatively cool compared to the bottom part. And so we're going to want to centrifuge these because 40 microliters, it's a decent amount of liquid, but we still want to make sure that we have all of the liquid available to be able to load our samples. So we're going to do a quick centrifuge of these in our microcentrifuge. So here is our microcentrifuge. You can see we've got, I don't know what is in here, like some weird stuff. I'm going to have to clean that out later. That is not normal. That's not supposed to be in there. But we're going to go ahead and centrifuge our samples. So you can just kind of put these in here. I've got 14 samples, an even number, which is important. So I'm just going to kind of put these in here, 7 on one side, and then I'll start putting them in opposite each other here. So we'll have a couple of open holes. Okay, we've got a lid that we have here. One of the things that's, and I don't realize it that I'm even doing it, you have to sort of put your finger here to hold this so that you can put this on, because if you just try to do it like this, it won't work. You have to hold this kind of still so that you can turn this and you'll hear it lock. You're going to close this up here. 30 seconds should be fine to do this, so we're just going to hit start. Maximum speed is fine here. We're just really looking to, I mean, if we could kind of shake these with our hand and get that water down, that would probably work, but we're just going to use this instrument here to kind of get them down. And it literally, I'm just going to stop it early. We don't even need to let it go that whole 30 seconds. This is just to concentrate that water vapor that had condensed on the top. Not as much of a problem when we have 40 microliters here, but if we had 10 microliter samples, we would definitely want to make sure we did that. Kind of reverse the process here. You got to hold this in order to open it. You're going to turn it the opposite direction. Your lid comes off. And we're just going to take our samples out. You can see there's not really much that was condensed on top here. So we're going to get all these samples out and then we'll be ready to load. All right, so importantly, we've been letting this sit for a little bit while we prepared our samples. We can definitely see that the level of the water is where we want it to be. So that's really important that we didn't have a gel that was leaking. So to load your samples, again, we're going to load 20 microliters here. Actually, I'm going to change this to be 15 because we knew that the maximum on our gel well capacity, it said was 15 microliters. So I'm going to take and load a few of these samples and then we'll show you the gel when it's all done. So when I load, I like to use a finger here to kind of keep this steady. You're going to put your pipette tip down so that it's between the two well plates. And I'm going to slowly start releasing. And I can see that dye solution kind of fall in. And I want to make sure that I release all of this solution before I pull my pipette tip out and let my finger out. All right, so our gel is loaded. We can see all of our samples in our wells. We only had 14 samples there, so that 15th one is blank. Okay, but now what we're going to do is we're going to take our cover and we're going to put it on. We have to make sure that we match red and black. So that red was on the right there. So we're going to see, oop, and you know what we have to do? Nope, this has to just go in the back. I forgot about this. This one is fine. We'll just pick this up. It actually has to be in the back. That's why it started out in the back. Because in order to line up with this, it has to be in the back. So now that'll work to line up. I'm going to put that on. Okay. Now we're going to plug our leads into our power supply. There's 4 spots. You can actually run 4 gels here. Doesn't matter which one you use, but again, we need to make sure we match black and red. I'm going to turn on the power. Now, if you just press run here, it would give you an error message because it's thinking that you want to have this be where you want to go. So we're going to use our up and down to kind of indicate we want this to run. And if you press and hold it, it'll go quickly. We're going to put it at our maximum, which is 200 volts. Once we get it up to 200, then you're going to press the little run key. Yep. And we can see that it is starting to go. If there was something that wasn't connected right, we would get an error message here. You always want to come and look at your gel. You should see bubbles that are forming. And so in the back, let me see if I can come down here. In the back on the wire there, you can see bubbles that are forming. You can see them kind of coming up through the back. And importantly, we're going to check in just a minute and we'll see that we can see that blue dye kind of making its way through the gel. You never want to walk away from things like electrophoresis and centrifuge until you know that they're doing what you want. So we're going to kind of give this a minute and then we'll see what happens. All right, so we definitely can see our dye is migrating in the right direction, so we can feel free to walk away from our gel now. We're gonna let it run so that the dye is probably about 2/3 of the way down, and then we'll disassemble our gel and start our staining process. All right, so our gel is, the dye has migrated. We probably could let it go a little bit further, but I think we're gonna be okay now for what we need to see. So I'm just gonna go ahead and I'm gonna hit the run button here, which kind of stops my run. Just to double check and make sure that everything is sort of disconnected from kind of a power standpoint. I always unplug this before I touch anything with my electrophoresis chamber. I'm going to take out our casting system here, and you can just kind of pour this in here. This tends to make a little bit of a mess, so we just need to make sure we clean up our counters pretty well here. I'm going to sort of open this back up, and we're going to need to break open these gels. Okay. So I'm going to take this guy, we're going to come over here because this is where I'm going to kind of have my gel here. So these are intended to be disposable. If we start using different plates where we actually make these, then our plates will probably split apart a little bit easier. But this is a little key here. You can kind of match up these triangles, and that allows us to literally come in. And I know it sounds terrible. It sounds like you're doing something awful, but it's actually what you're supposed to do. We need to actually break this disposable gel system apart. So I'm kind of putting it in all 4 areas here. Now the biggest thing when you're separating gels, and it'll be true for this here, if we start making our own plates, we want to make sure that the gel is only sticking to one plate. So as I open this up, I'm going to kind of be looking to see where my gel is sticking. And actually we can sort of see it here. It's sticking to this bottom plate. So that's good. So I'm going to go ahead and take this off. I'm looking for, let me grab my water. So the next thing that we want to do is we need to be able to stain this gel. So we're going to be using a Kumasi blue staining system. And it's these 4 bottles that are here. So they're labeled A through D, and they contain an acetic acid solution with different concentrations of Kumasi blue. The highest is in our A solution, and we go down to our D solution, which actually is only acetic acid. You can actually see probably that there's no dye that's in there. So what we're going to do here and how this works is we basically are going to blast our gel with so much Kumasi blue that it stains everything. And it's just going to look like a giant purple Jell-O jiggler, if you will. Then what's going to happen is we go through the rest of these solutions, we're going to slowly start removing the dye from the background of the gel. Remember, Kumasi blue is a positively charged dye that's going to stick non-specifically to all proteins. And so it's basically going to be letting go of any spots where there aren't protein. So as we use these B, C, and D solutions, we're going to slowly be destaining the background until at the very end, and we'll leave this sit overnight with a Kim wipe, we're going to be removing so that we can have what we call a water clear background. So it's just as clear as we see here, and the only dye that's remaining is what's with the protein. I like to think of it as the protein being like glue that's there, and we essentially put a whole big amount of glitter that's on there. And until we kind of get the rest of that glitter off, we're not going to see where our protein is. So the next step that we're going to do is we're going to take this gel off of this plate here. So I like to use a squirt bottle here. Now, if we do actually use our nozzle like I'm using here to kind of get under the gel and kind of try to release it, we do want to make sure that we rinse off this nozzle so that it's not contaminated if we need to use this water bottle for something else. But just kind of coming in here, and eventually it'll get to a point where the gel can just sort of slide off into our little, this is a pipette tip box, yep, but it's going to be something that we're going to use to stain our gel. So once we've got this off here, you can see when you have the gel in here, it moves around pretty easily. I'm going to have you follow me over to the sink here. I like to use this sink because it's already stained, but if you put your finger on the gel here, you should be able to slowly pour, and you can pour solutions out here. And the gel's going to be stuck relatively well to the bottom here, so you don't need to worry about that falling out, but I still kind of keep a finger on here. So what's going to happen here is we're going to add, let's go and put this first gel solution in here. I'm going to add solution A, and I just sort of eyeball how much I'm adding. But when you see this come out, you're going to see how dark purple this is. So it's very dark. I'm going to add about that much. I'm going to cover this up, and then we're going to go microwave it. So we're going to microwave it for a minute, and it's going to be very hot. And remember, there's acetic acid and there's actually methanol that's in here. So when you open up the microwave to take it out, take a breath and hold your breath, because it's not anything that's really super toxic or anything, but it's just going to be like a giant bag of salt and vinegar potato chips. It's really, really strong. So we're going to take this over here. To our microwave. Just going to put it in here for 1 minute. Oh, and these don't, there we go. So we'll check back in a minute. All right, so I can already smell this a little bit. I'm not going to talk too much because I need to hold my breath. So I'm going to open this up and I'm going to take it out. We're just going to let this sit on the bench top for probably about 4 or 5 minutes, especially this first one. We want to make sure that that dye really sets in. All right, so this has been sitting for a few minutes here. And what I'm going to do is I'm going to dump this down the drain. So we're going to come over here. Again, it's a little bit hot, so I don't want to burn my fingers. So I'm going to put some cold water in here. Well, I don't know what's going on with that. I'm just going to put some water in here. And I'm going to put my finger down on the gel. And then I'm going to pour this down the drain. So if we look, we can see that pretty much the entire gel is purple. So what's going to happen is we put these next few in, what's going to start happening is the background is going to start destaining. And then what we'll have is the protein will retain this same purple color, but the background will become lighter and lighter. So we're going to go and put our next solution in. So this was solution A. So now we move on to solution B. The exact same process. We're going to add enough in so that it kind of fills up there. You can see that it looks a little bit lighter. It was not as intense of a blue. I'm going to cover this, microwave it for a minute, let it sit for 4 to 5 on the bench top, and then do the same rinse. So we're going to do that with buffer B, buffer C, and then the last time we do this with buffer D, when we add this solution in and we microwave it and then we let it sit, we're going to put a Kim wipe on top, and then we're going to just let it sit overnight, and then we'll see what that looks like tomorrow. So we had a Kim wipe in with our last solution. You can see that Kim wipe has absorbed a lot of that dye, but what was really nice is we got a nice water clear background here. So what I'm going to take is I'm going to take this gel out here. I'm just going to set it on a piece of saran wrap with a piece of white paper underneath, and this is going to be our low-tech mechanism for taking a picture of our gel.